Hello students, as we had discussed that in the next lecture we will be discussing about the Boolean algebra. Now for your part 1 you have these three things. One is proposition logic, then Boolean algebra, and then the computer hardware. So we will be discussing about these three parts in this section: proposition logic, Boolean algebra, and computer hardware. Now what do you understand by proposition logic? Or first of all, let's talk about what is a proposition. A proposition is a statement which results either to true or false. Like if I say it is raining today, now it can be either true or false. What is your name? It results something, Santosh, it can be Ashish, it can be hello, anything. So it is not resulting to true or false. So such a statement which results either in true or false is known as a proposition. Now this proposition can be in two types. It can be either a simple proposition or it can be a compound proposition. Simple proposition and a compound proposition. When we talk about a simple proposition is a statement which is having a single statement, or a single proposition is known as a simple proposition, and when we have two propositions which are combined together, this forms a compound proposition. So what is a simple proposition? A single statement is known as simple proposition, and this combination of two propositions is known as a compound proposition. Like I say, if statement A is, it will rain today. B, you will get wet. If it will rain today, then you will get wet. I can say statement A, you must work hard. Statement B, you will get good marks. I can combine it as no, if you study hard, then you will get good marks. So whenever we talk about these propositions, to connect two propositions, we need certain connectors, right? To connect two propositions, we need certain connectors. Now these different propositions to connect, they can be different propositions, like we have conjunction, then we can have disjunction. Okay, disjunction, conjunction, disjunction, it can be there, conjunction is there, disjunction is there, negation is there, negation, then we have double negation, and then we have implication. Now if you talk about conjunction, a conjunction is a statement which is just like an AND operation, right? AND operation means when both are true, then the conditions are true. So conjunction, if I say that a conjunction is a statement where there are two connectors joined with a AND operator. There are two propositions which are joined by the AND operation. So like if I say Rajesh is a good boy. Rajesh is I make it a student. Rajesh is a good student. Rajesh is a good singer. I can combine Rajesh is a good student and he is a good singer. So what is happening, that I am using the AND operation to combine these two statements. Like if I say, let us make a truth table. This is statement A, this is statement B, and this is A dot B, right? This dot is used for conjunction. Now 0, 0, 0, 1, 1, 0, 1, 1. 0 stands for false. False and false. This will be false. False and true. This will be false. True and false. This will result to false. true and true, this results to true. So this is the conjunction. Now when we talk about the conjunction we can represent it as the symbol dot, or we can use the symbol this to get the conjunction. Okay, so this is conjunction. Now let us talk about disjunction. Disjunction, what happens? Disjunction is a statement where we use or operation. Or means either of the conditions are true, the output will be true. Like if I say for disjunction, I have A, this is B, and this is A plus B. We can denote it as like this symbol. Right? This is disjunction. Now when we talk about disjunction, this is false, false, it will result to false. 0, 0, 0. If I say false, then I say true. Means it is 0 and 1. In that case it is true. That's 1. Then if I say true, then false, 1, 0, it results to true. That is 1. Then if I say true, true, it results true. That is 1, 1, it results to 1. So this is disjunction. Third one is negation. Negation is a not. Like if I say A, so not of A, not of A, I apply this not operation, so this will result to a negation. So to represent a negation, we A bar I say, right? Now if it is 0, it is 1. If it is 1, it is 0. So the negation results to complement. Again, double negation. A double bar. So A double bar, it will result to A. For example, I have 0, a complement, and then again its complement. So this will result to 0. If I have 1, its complement 0, and again its complement results to 1. So this is double negation. So this is the double negation part. And then we have implication, that is the conditional operation. Implication. If I say A implies to B, A implies to B. Now what is implication? If I say if then, if you study well, then you will get good marks. So what happens in case of implication, like we have A, B, and if I have F, 0, 0, 0, 1, 1, 0, and 1, 1. If you talk about this implication, so it results to, when it is 0, 0, it results 1. If it is 0, 1, it results 1. 1, 0, it results 0. 1, 1, it results 1. So when we talk about implication, A implies to B. It can be written as A implies to B, or we also write A implies to B. In either of the cases we can write A implies to B. Then we have double implication. A double implies to B. If and only if. If and only if, that is double implication. In case of double implication, what we get, that when it is both the inputs are 0 or both the inputs are 1, in these two cases it results a high value. In 0, 1 and 1, 0, it results to 0. So if we talk about this proposition, so proposition you can get either of these propositions, what is simple proposition, what is compound proposition, all of these connectors, you can get either of the connectors and you can be asked to write about them. You may also be asked to draw a truth table of any of these statements which involve the proposition logic. For example, if I say, if we have a statement A implies to B, A implies to B, or B implies to A, right? A implies to B or B implies to A. You have been asked to draw a truth table of this expression. Now, I take A and B here. This is A implies to B, this is B implies to A, and this is A implies to B, B implies to A. Okay, so what will be here? 0, 0, 0, 1, 1, 0 and 1, 1. If we talk about A implies to B, so 0, 0 is 1, 0, 1 is 1, 1, 0 is 0, 1, 1 is 1. If I talk about B implies to A, 0, 0 is 1, 1, 0 will be 0, 0, 1 is 1, 1, 1 is 1. Now we get these two values, A implies to B and B implies to A. Then we have, for example, if I talk about this statement, we have this disjunction which is combining these two terms, and to understand this disjunction, we can consider it as the two terms are being operated. Now, you see 1, 1, it will result to 1, 1, 0 results to 1, 0, 1 results to 1 and 1, 1 results to 1. So this will be the final truth table of the given proposition statement. You need to define this, you need to define this, then you get this, and based on these two, we get these values. So I hope this is clear to all of you. Now, when we talk about our expression involving a conditional statement, A implies to B. A implies to B, if I say, in this case, if this is A implies to B, now A is known as antecedent. A is known as antecedent and B is known as consequent. A is the antecedent and B is the consequent. Now, depending upon this, we can have converse, inverse and contrapositive of these statements. If I say converse, inverse and contrapositive. Contrapositive. Now, what is converse? When we talk about converse, if there is a statement A implies to B, then the converse of this statement is a statement after the interchange of antecedent and consequent. So, converse of this statement will be B implies to A. Right? Converse of the statement A implies to B is B implies to A. Next we talk about inverse. When we talk about inverse, the inverse of a statement is found by the negation of the antecedent and the consequent. Negation of A implies to negation of B. That is inverse. And then the contrapositive. Contrapositive will be negation of B implies to negation of A. That is contrapositive. Now, if we talk about converse statement, like if you say, if you study well, then you will get good marks. That is a statement. If you study well, then you will get good marks. When we talk about converse, you will not get good marks if you do not study well. Inverse, negation of A. If you do not study well, then you will not get good marks. Contrapositive, negation of B implies to negation of A. If you do not get good marks, then you have not studied well. So, using the statement, you could be asked to obtain the converse, the inverse and the contrapositive of the given expression. Like if I say, if it rains, then the sky is cloudy. If it rains, then the sky is cloudy. It is a statement. Now I want a converse. If it is cloudy, then it will rain. I want the inverse. If it does not rain, then the sky is not cloudy. And if it is not cloudy, then it will not rain. So I can get the converse, the inverse and the contrapositive of the given expression. Once you are done with this part, then let us talk about certain other expressions. There is a term called tautology. Then there is contradiction, and then we have contingency. Now, what is tautology? A Boolean expression which results to all values true, which results all statements outputs true, that is known as a tautology. For example, if I say a plus 1 or operation, if it is 0, 0 plus 1 is what? 1. If it is 1, 1 plus 1, the OR operation is 1. So this statement will be a tautology. Second one is contradiction. A statement in which it results false in all the conditions is known as a contradiction. Like if I say a dot 0 and operation. 0 dot 0 is what? 0, and 1 dot 0 is what? It is also 0. So it is a contradiction. Then you have a contingency. If I say a plus b. Now 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, 1 plus 1 is 1. Now such expression which results either both combination of true and false, that is known as contingency. So we have tautology, contradiction, contingency. You can be asked either the definitions of this, or you could also be asked that an expression is given and you have to identify whether it is tautology, it is a contradiction, or it is a contingency. Next we have different properties of the Boolean algebra, right? Different properties of Boolean algebra. You need to understand these properties as well, because you might get questions. You can be asked in the MCQ question that a statement is given, you have to identify what is this law representing, or you could also be asked about the different purposes or the different definitions of those laws. First one, properties of 0. Properties of 0. Now, properties of 0 we have a plus 0. A plus 0 is always a. Like if you have 0 plus 0, it will result to 0. If you have 1 plus 0, it will result to 1. Then we can have a dot 0. 0 dot 0 is 0 and 1 dot 0 is 0 again. So we have these two properties of 0. A plus 0 is a and a dot 0 is 0. Then second is properties of 1. Here we have a plus 1 is 0 plus 1 is 1 and 1 plus 1 again is 1. So it is 1. And again a dot 1. 0 dot 1 will be 0 and 1 dot 1 will be 1. So it is a dot 1 equal to a. So this is the second law, that is of laws of 1. Then we have absorption law. Absorption law. Absorption law states that a plus ab equal to a. A plus ab is equal to a. The second absorption law will be a dot a plus b is equal to a. This is the third law, absorption law. Fourth law. For every law you need to understand its logic and the statement. Next law is involution law. Involution law. This is also known as double complement law. A double bar is equal to a. We already discussed. So involution law is a double bar is equal to a. Then next we have the complementary law. Complementary law. This is a plus a bar is equal to a plus a bar. For example, here I have 0, 0 plus 1 equal to 1, 1 plus 0 equal to 1. So a plus a bar equal to 1. And the other complementary law will be a dot a bar equal to 0. Next law we have the commutative law. Commutative law states that it states that a plus b is equal to b plus a, or A dot B is equal to B dot A. Then we have associative law. Associative law. Now the associative law states that A plus B plus C, A plus B plus C, this is equal to A plus B plus C, or we can say A dot B dot C is equal to A dot B dot C. So this is the associative law. Next we have distributive law. Next one is distributive law. These all laws you must have studied in mathematics also. So when we talk about the distributive law states that A plus B dot C is equal to A plus B dot C is equal to A dot B, A plus B dot A plus C, or we can say A dot B plus C is equal to A dot B plus A dot C. So this is the distributive law. Next we talk about, so these were the laws of the distributive law. Next let us talk about a theorem, that is De Morgan's theorem. De Morgan's theorem. Now De Morgan's theorem states that if we take the complement, like if I say A plus B bar, this is equal to the complement of the A bar dot B bar. In normal language you can define it as, we can say this bar, we are breaking up this bar, break the bar and change the sign. I broke the bar, I change the sign. Like the other one, A dot B bar is equal to A bar plus B bar. So this is the second De Morgan's theorem. Now sometimes you can also be asked to prove a theorem or to prove a statement. If I say I have to prove A plus B bar is equal to A bar dot B bar. If I have to prove this theorem, what I can do, again I will make a truth table. A, B, A plus B, A plus B bar, this is A bar, this is B bar, and this is A bar dot B bar. Let's solve it, students. 0, 0, 0, 1, 1, 0, 1, 1. A plus B, 0, 0, 0, 0, 1, 1, 1, 0, 1, 1, 1, 1. A plus B bar, it becomes 1, 0, 0, 0. A bar, 1, 1, 0, 0. B bar, 1, 0, 1, 0. A bar dot B bar, the AND operation, 1, 0, 0, 0. Again, A plus B we had taken this one. Now if you see, this part is the LHS and this one is the RHS. This is my LHS and this is the RHS. Now you can see LHS equal to RHS. Hence, it is proved. So sometimes you could be asked to explain a law and then verify it. So that will be the way in which you will be verifying it. You will be making the truth table and then you can verify those statements. So I hope this De Morgan's theorem is clear to everyone. Next we have again a duality theorem. Duality theorem. The duality theorem states that starting from one Boolean expression, we can obtain another Boolean expression by changing each and to or, changing each or to and, changing each 0 to 1 and changing each 1 to 0. So what is the De Morgan's duality theorem? The duality theorem states that starting from one Boolean expression, you can obtain another Boolean expression. Now let us see. If I have A dot B plus C dot 1, let us get a different theorem from it. It will be A plus B dot C plus 0. So from this expression I got this expression. So this is the dual of the given Boolean expression. So for getting a dual, you need to change each AND to OR, each OR to AND, each 0 to 1 and each 1 to 0. One more thing, when I was discussing about the De Morgan's theorem, as I told, it is used to get the complement of a given Boolean expression. It is used to get a complement of a Boolean expression. So the De Morgan's theorem, for example, if I say I have a statement f is equal to a plus b dot a plus c. Now the question is, find the complement of this given Boolean expression. Find the complement of this given Boolean expression. F bar is equal to, I'll apply the bar, a plus b dot a plus c, its complement. Now when I'm breaking this bar, this becomes a plus b bar dot plus a plus c bar. Now when we are breaking this bar, it is a bar dot b bar plus a bar dot c bar. So the complement of this given expression is this one. So this way you can obtain the complement of a Boolean expression. So this was all about your proposition logic. Now when we talk about Boolean algebra, so Boolean algebra, again basically it consists of the different parts and the different theorems. In that you will be getting certain expressions, the sum of product and the product of some expression and the different applications of it that we will be discussing.